uh, LR parsing, and we will be starting with SLR, or we can say LR0. Now, is this screen is visible? Is screen is visible?
Yes, sir.
Okay, thank you, Siddharth. Now let us start with this. Since in last lecture we have started this SLR or LR0, the key pointers I am going to tell you again for just quick review. Key pointers include first, uh, augmentation of grammar, which is whatever is being provided to you, augmentation that we are going to do. And second, we are going to compute LR0 items. Okay, and to compute these LR0 items, what we need to apply dot operator. This augmentation and implementation of dot operator we have seen in last lecture itself. So you can refer back to those points as far as augmentation of the grammar and computation of LR items. That is like how a dot operator is being applied, and what if the dot is placed before, or how you can read those closures. That you need to understand. Like means whatever the position of dot matters. What if the dot is before the variable or non-terminal symbol, and what if the dot is after the non-terminal symbol, or if there are consecutive non-terminals placed in a production, how you can interpret those productions with respect to the dot operator that we have discussed. Okay, so let us take an example. Uh, we are going to perform SLR parsing. We are going to perform SLR parsing on following grammar. SLR parsing on following grammar. Grammar is very simple. S implies capital C, capital C. C implies small c, capital C, and D. Okay, so this is the grammar. So this grammar is being converted into an augmented form. It's augmented form. So the new grammar becomes S dash implies C C, C implies small c, capital C, C implies D. Okay, so sorry, sorry, this is not. So this is just an S actually. S dash implies S. Okay, so this is S. S dash implies S. S implies CC, C implies small c, capital C, C implies D. So we are going to refer this with the production numbers. This is zeroth production, this is first production, this is second production, and this is third production. So there are total 4 productions here. S dash implies S, S implies CC, C implies small c, capital C, C implies D. Okay, this is the case. Now, once you have an augmentation of the grammar, what is the next step? Next step for you is computation of LR items. Okay, so we are going to compute LR0 items. Okay, and to compute LR0 items, what we need to do is we need to apply dot operator so that closure set can be formed. Okay, so that the closure set can be formed. So initially we will apply closure set. We will formulate a closure set. So we'll apply dot onto S. So which means if the time we apply dot onto a S, which means my production will be S dash implies dot S. So what does it mean? It means that we are expecting some of the inputs from S. So since dot is applied over S, what we need to do is that we need to collect all the productions of S here. So now here we just have only one production. So means what? S implies dot capital C, A and C. So dot is applied over now C. So we need to collect all the productions that are associated with C. So which has become C implies dot C capital C implies dot D. Okay, so this is going to be my closure set. So I am going to refer this as I0. Okay, so please try to understand the closure set is we are expecting some of the inputs from the start symbol. So dot is applied over start, S. Then S, whatever the production that are associated with S has to be taken forward. So S implies CC is the production. S implies CC is the production. So dot gets applied over C. So which means that C is a non-terminal. So the production associated with C has to be included. So that is C implies small c, capital C, C implies D. So dot is applied over this. Okay, so you have got the initial closure set that is I0. Then you need to shift this dot now, right? So means what? You need to move I0 with dot s. So which means that we need to find out production uh, from I0 such that there is a dot s included. So we have one production into a set of I0 where dot is included, so that we have expected some of the inputs from s. So we included all the production associated, which means that we generated input. Now we can shift a dot. So which means that now my modified the dot gets shifted, so it becomes s dot. So we don't have this production. So here we will say that this is going to be a new set called I1. Okay, so next is what we can do is we have to go with I2, I0 with dot capital C. Okay, dot capital C. So which means that we need to see the production which is available into I0 where dot is before C. So which means we have expected some of the inputs from C, and that is why we included all the productions of C into the set. So which means that C is being produced. Now we can shift up dot. So which means that we have a production say S implies capital C dot capital C, comma. Now see, dot is applied before this C. So which means again you are expecting some of the inputs from this, right? So which means that you need to collect all the associated productions with respect to C, and this is going to be like this. So now this set we don't have, so we will say this is going to be I2. So you have got two sets now, I1 and I2. So next what we can do is that can we go with I2, I0 with small c, I0 with small c. Okay, and this is the capital C. So which means that we have to see a production in which in I0 such that dot is before small c. So dotted before small c means here C implies small c dot capital C, right? Small c dot capital C, comma. So dot is applied over this now C. So which means we need to take all the productions of C here again. So this is capital C, comma, C implies dot. So which means this is going to be my new set called I3. So this is small c, capital C, C implies dot, small c, capital C, C implies dot. So you have got I3 new set now. Now next is, can we go with one more variable, that is dot D here? Yes, you can go because that is exist here. So C implies you have to shift a dot. So this is there. You mark it as I4. Okay, now once you have figured out with I0, you need to see with I1. So with I1, can I go with some input? No, because it is completely derived. S dash implies S dot. S dot means dot is after a non-terminal or variable, which means that the string is being produced from S, so we cannot proceed. Okay, so let us look at, can we go with the I2 with the dot C. Yes, we can go with I2 with dot C, which means we need to write with I1 we are not going, but with I2 we are going with capital C dot capital C, which means the production is going to be S implies capital C dot get shifted. So means here C is being reduced. So this is going to be my new set. This is called I5. Okay. Now let us go with next I2 with. Okay, you just closely look at I2. I2 with the small dot C here you can go. Okay, with small c you can expect the input. So this is small c. So which means dot has to be shifted. So C implies small c dot capital C. So since dot is getting shifted, it is being applied over C now. So it means that you need to add all the productions related to C here. C implies dot. Okay, but see, the same set we are going to have means look at I2. Once this dot gets shifted, then we are going to have production. I'd include a production of this C. So it means we are going with I3 here because I3 has the same set of values. Okay, so I2, when I2 is going with the dot D, it means C implies D dot. So which means C implies D dot means I4, because I4 has the same values in it. Okay, so now you have got these things, right? So you have explored with I2. Now can we explore with I3 now? Because I2 we have explored up to D. Okay, now can we explore with I3 now? Yes, we can. We should go with I3 here. So let us go with I3. I3 with what? I3 with which input we can go? I3 with the dot C, capital C we can go. I3 with dot capital C we can go. So which is giving me an output, say for example, C implies small c, capital C and dot. Small c, capital C and dot. So do we have this set? No, we don't have this set. So we will write it as I6. So this is going to be my I6. Okay, CC dot. Now next is I3. Next input we will see I3 with small d. With small dot c I can go. So it is I3 with dot small c I can go. So which means this dot c. So dot is getting shifted. So we are expecting some of the inputs here. C implies small c dot capital C. Okay, C implies dot get shifted. So C dot is applied over C. So we need to collect all productions of C here. Dot C, capital C. C implies dot D. So this is what? Again, the same set we are going to get. This same set we are going to get. We are going to get this as I3. Okay, I3 with small c, we are getting I3 only. Okay, now let us go with I3 with dot D. So I3 with dot D will be I3 with dot D will be here. It will be C implies D dot. Okay, this is gonna be I4 now. So what this is going to be I4. So now you have figured out, just try to understand. You computed the closure set. This is the closure set. This is the augmentation grammar. This is the closure set. Now you have computed a closure set. After computation of a closure set, you are trying to you're trying to apply non-terminal and terminal symbols. So look, just let us look at here. What are those non-terminals that are available here? Non-terminal symbol are S and C. So as S dash also a non-terminal. So they can also be referred as variables. Okay, they also being referred as variables. Now next is, what are the terminal symbols that you have? The terminal symbol, you just have only terminal two symbols. Okay, so this is C, D and dollar. Now why dollar? Dollar is input end marker. C and D are nothing but the symbol, terminal symbol here. So these are the non-terminal and terminal symbols. Okay, so these are the terminal symbols. So you have got these sets. I hope set computation is clear. Let us revise this. First you have got a grammar. Once you have got a grammar, what you are going to do is, once you have a grammar, this grammar, once you have grammar, you are going to compute a augmentation form of this. So you computed augmented form. This is going to be the augmentation of a grammar. So what exactly it is? It is uh, S dash implies S implies C, capital C implies small c, capital C implies D. Okay, then once we do this, we are going for a computation of LR0 items. So these are nothing but the closure set. So here we are applying a dot so that the closure set can be formed. So we applied dot. So dot is first applied over the first production, that is S dash implies dot S. So since dot is applied on S, the S associated production has to be included. So there is only one production that is associated with S, and that is S implies dot CC. So S implies dot CC means dot is applied over C. Now, since C is a non-terminal and dot is before C, so we need to include all the productions of C into the same set also. So C implies small c, capital C is the production, so dot is applied before small c. C implies D, so dot is applied before small d. Okay, so this is how. So once you have got I0, you can prepare a, you can collect the states, from I0. So I0 with variable S, I0 with variable capital C, I0 with the terminal symbol small c, I0 with terminal symbol D. So you will form a new sets accordingly. Accordingly, the dot is getting shifted. Okay, once you shift up with the dot, you need to prepare a transition diagram. So which signifies like how it is being reduced and shifted. So you have got a transition diagram here. Okay, so what is exactly the transition diagram? Transition diagram is a pictorial representation of states with over inputs. So the vertices are the state members. Say for example, our first vertex is I0. So I0 with dot S, I0 with dot S, I0 with dot S will go with I1. So we will say this is I1. Okay, with dot it is going. So I0 with dot capital C, I0 with dot capital C will go to I2. Then I0 with dot small c will go to I3. So this is going to be my I3. Now I0 with dot D will go to I4. Okay. So I3, I2, I1, I2, I3, I4 we did. So I2 with capital C, I2 with the dot capital C, it will go to I2 with dot capital C, it will go to I5. Okay. Next is I2 with small c. I2 with small c will go with this is dot c. Small c will go with I3. I2 with small d will go for I4. Okay, small d will go for I4. Now I3 with capital C will go to I6. So we'll say here with dot capital C will go with I6 here. Okay. Now I3 with the small c will go. I3 with the small c will go to with the small c will go to I3 itself, and I3 with the small d will go to I4. So this is with dot d. Okay, so you will find that if you look very carefully, you will find that uh, you'll if you look at very carefully, uh, what you will find that at I1 once you go with this I1, the dot gets shifted, so it will become S dot. If dot gets shifted, it will become S dot. Okay, so this is interesting thing which you need to understand now. look at here. So with this, the dot gets shifted. So here I'm using a green color. So you'll find it that okay, S dot, it becomes S dot. Now see, with if you follow this I0, I2, and I5, you will find that at this point I5, your production will be C dot here, right? So means what, you have produced everything. So just follow this, you'll find that you'll produce everything. Okay, if you look at I0 with I3 and I this, you will find that this is small c, this is capital C. So in case of I6, you will find that it is dot C dot. So means what, it is small c, capital C, and dot at I6. So means what, see, this is getting completed in I6. Okay, so this is got it. Okay, and in case of I7, it is C and dot. Okay, so means what, if you whatever the green representation that I have put, you'll find that there you will find the reduction is being happened completely. Okay, so reduction is being happened wherever you find the repetitive kind of thing. You can see that I3 is coming into picture for generation of repetitive things. Okay, so this is how, what exactly is. Okay, so once you have got a transition diagram, next important phase point is, as you know that in case of a parser, you have got this as an input string, right? This as input string. This is input string. Okay. Then what you have got? You have got this as a stack, right? And this is the parser. Okay. So here you have got a parser routine. Okay, the routine means the algorithm which we are going to perform. Only this is going to change, and this is got a parsing table. Okay, so this is parsing table. Now we understand that the input goes into this way, and this is being placed into stack. This is what is general architecture. Okay, now once you have computed the LR set, LR0 sets, then you have computed transition diagram here. Now it's time to prepare a parsing table right here. So this is for this is again very important. We need to go for parsing table. So let us prepare a parsing table here. Okay, now as we have discussed, a parsing table has some attributes, right? And those attributes are like this. Um, it has two parts which we have clearly understood, that is called actions, right? And next part that is called as goto, right? So action and goto. So these are two parts. Then there are states. Okay, so how many states are there? So I0 to I6. So I think so we have a six states here. Okay, six states, right? So we'll just mark it. This is say I0, I1, I2, I3, I4, I5, and I6. So there are total seven number of states. Okay, then in case of action performs with terminal symbol. Try to understand, right? So this gets performs with terminals, and this is performed when you are dealing with non-terminals oblique variables. So we need to mark the entries, no? So in this case, all terminal related entries we will be marking into actions, and all non-terminal related entries we will be marking into okay, so figure out the inputs, right? So in case of actions, so the terminal inputs we have is C, D, and dollar. So we will say that we have got C, we have got D, and we have got dollar. Why we included dollar? Because our start symbol is in grammar, our start symbol is yes, right? And yes is going to be on the top of the stack when we are going for shifting and reducing, right? So S has to be reduced if dollar is in the follow of S. right? So means what? Once you have come across with the situation like I0 s dot, so dot means what? You have completely reduced yes. So ultimately dollar is in the follow because you're expecting some of the inputs from the dollar because dollar is in follow of s. S is the start symbol. So in that case, to represent that, we need to have dollar here. So dollar is the accept. Okay, then in case of goto, we need to draw the variables. So the variables are, say for example, our variables are non-terminal sc, right, and s dash, and s dash is the start symbol, so we are not included. We use s dash as an augmentation, so s is being come into the right hand side of the production. So the variables that are for us will be, say for example, they are S and C. So we'll write it, say for example, C and S. Okay, so there are two variables, C and S. Okay, now let us go ahead with this now. Now, when you are going for shifting, so when you are expecting some of the inputs, so I0 with, look at here, I0 with I0 with I0 with the variable dot s will go to the state number one. So we will say that this will I0 with the variable will go to set one. Okay. Then I0 with capital C will go to two. So this is two here. Okay. I0 with small c will go to I3. So we will write that this is a shift move, right? Because we are shifting that c, which is the terminal symbol, onto the stack. So we are going to write this as, which is this? This is third state. So we will write it I0 with small c will be uh, S3. Okay, I0 with small 3 is S3. Okay, now look at I0 with D is S4. Okay, now look at, no, I0 is completed. I0 has what? I0 has four states here with two non-terminals and with two terminals. So with two non-terminals, we are writing it here. The state number 1 and 2. But with two terminal symbol, we are using a shift move, that is S3 and S4. Okay, this is going to be S3. Okay, so this is S3 and S4. Okay, now look at Ivan. Now look at Ivan. Ivan, we are not going anywhere. Okay, we will see that. Okay, Ivan is completely reduced. S is completely reduced, and which is being followed by dollar. So we will say right here. We'll say right accept, because S is getting reduced completely. S is getting reduced completely, so S is accept. And only you need to understand, like when we will announce accept condition if and only if a dollar is in follow of the start symbol. So dollar is in follow of the start symbol, and what was our start symbol? Our start symbol was yes, and yes is being reduced, and dollar is in follow. So we'll say yes is completely reduced, and I1 uh, with the Ivan, we are not moving with any of the either terminal, non-terminal, but it is being reduced, so it is accept. So look at I2, and we don't have any set here, and also will corresponding to I1 because we are not moving with I1. See, I1 is yes dot. Okay, so it is closed. Now look at I2 now. So I2, if you look at I2 means what? Here, this set you need to see. Only three representations we have. I2 with dot C, that is capital C, we will be moving to 5. So I2 with the dot C, we will be moving with go to state number 5. I2 with capital C will go to state number 5. I2 with small c we're going with S3, right? Because this third state, right? So this is what we are going to write here, S3. Okay, and I2 with the D is going with S4, shift 4. Okay, so we are going for S3 and S4 here, shift 3, shift 4. Okay, because we are going to that particular state. Okay, now look at I3. I3 we are going with dot C into a sixth state. Okay, so with C means what? A variable. So we non-terminal. So we'll write it here 6. Okay, then for small c and small d, again I3 and I4. So means what we are going to write S3 here, S4 here. Okay, so we have got S3, S4 here. We have got S3 and S4 here. So S3, S4 with small c, small d. Okay. Now what about S4, I4, I5, and I6? Look at here. I4, this calls for reduction. I6 call for reduction, and I5 call for reduction. So I4, I5, I6 is calling for reduction, and which means that CC dot, which means that everywhere it is getting reduced. Now look at I4, I4. So dot C, right? So here we have to write reduction purpose, reduction. So we'll say here with respect to with I4 we are not moving ahead, with I3 we are not moving ahead, all right, and with I6 we are not moving ahead, right? So now you look at here, and which production it is being done, you need to write here called R. This is R1, R2, and R3 production, reduced production. So look at I4. I4 is I4. If you look at I4, you'll find that it is D dot. So what does D dot means? D dot is the third production, right? So D dot is a third production. So with I4 we are going to write with C also we are going to write R3, D also we are going to write R3, and dollar also we are going to write R3, because I4 D is being dot, so it is D is being completely reduced. So this is with respect to reduction number 3. Now look at I5. I5 is if you look at I5, you will find that it is CC dot. Okay, CC dot means what? Which production you have got? A capital CC. Okay, CC dot. So we are going to write the reduction by using a production number 1. So that is why we have given a numbering to this, just to identify that which reduction going to happen. So this is R1, R1, and R1. Okay, so with I6, and now why we are writing into a terminal symbols? Because we produced all terminals using this derivation, right? So this reduction purpose. Okay, now I6, if you look at I6, you'll find that this is CC dot, C and C dot means what? This R2 is being coming into picture. So this is reduction by using 2. Right, so this is what is the completion of the parsing. So we need to go for 3 stages now here. So the key pointers, we need to go for augmentation of grammar, then we need to go for computation of LR items, then we compute LR items. Step number 3 is we are going to compute now here addition. We are going to compute a transition diagram, right? This is what is our transition diagram. So once we finish up with the transition diagram, we need to draw a parsing table, right? So you have to take this thing into a mind. Okay, so this is how once you have a complete parsing table, and parsing table has 2 moves, right? Here you need to provide 2 moves. One is you need to go for shift moves, and next you need to go for reduce moves. Okay, and how you are going to reduce moves? Reduce moves means dot is at the end. So what are the reduce moves? Look at here. These are the reduce moves, right? So these are the reduce moves. Look at here. These are reduce moves. So S1. So this is with I5. If you look at here, this is again here reduced. Okay, but they are variables. So I4, right, they are end actually. So in case of I4, you need to reduce, you need to figure out the reduce moves. I'll just mark it with the green. So the reduce moves are this: I5, I4 is reduce move, then R1 is a reduce move. That is, this is a complete reduce move. Okay, and I6 is a, right, and I look at I6 where it is this is I6 is reduced. So I4, I5, and I6. I4, so I4, I4, I5, and I6. I4, I5, and I6. And this is for accept we have taken, right? And these are reduced moves, right? We are writing R3, R1. So because they are not being computed further, they are final sets. So I4, I5, and I6. I4, I5, and I6 are the final sets. And we produce sets from I2, I3, right? I2 and I3. So I2 with the capital C is I5, I2 with the I3 with the capital C is I6, right? And I0 with the small d is I4. So I4, I5, and I6 are complete sets, final sets. So they are the so reduced moves are final sets, particularly final sets. Reduced moves are with the final set. I4, I5, I6 are the final sets. And R1, R2, R3 is nothing but this. So R1, this is R1, this is R2, and this is R3. R1, R2, R3. So R1, R2, R3. And rest are the shift moves. So if you look at the shift moves action part with terminals, right? And go to with variables, okay, or with non-terminals. So with the shift moves are written S1, S2, S3. So one represent the set number. Okay, so this is shift moves. So look at here. These are the shift moves. I'll just use another color so you can mark it clearly. So these are shift moves. Okay, so these are shift moves. Look at here. Uh, S2, S3, right? S3, S4, S3, S4 are the shift moves. S3, S4, S3, S4 are the shift moves, right? Okay, so we are going to write. And go to part, we are using non-terminals here. So these are go to. Okay, so